A rare visitor from deep space is in fact racing through our solar system, and it's breaking records on the way. Scientists have confirmed that the
3I Atlas, the fastest, oldest, and most mysterious interstellar visitor ever detected Milky Way. A ray visitor has entered our solar system, a fragment from the deep beyond, a traveler older than our sun itself. And it is moving so fast that even the gravity of the sun cannot hold it. Scientists call it 3I Atlas, the third confirmed interstellar object ever detected. But to the world, it is something far more dramatic, a messenger from another star system, racing through our neighborhood, leaving only fleeting clues before it disappears forever. From the moment of its discovery on July 1, 2025, by the Atlas Survey telescope in Chile, astronomers knew this was no ordinary comet. Its velocity alone, over 130,000 miles per hour, or 210,000 kilometers per hour, broke every previous record. Its path was hyperbolic, not elliptical. This meant one thing: it did not belong to our solar system. It was a true interstellar interloper, bound to no star, destined to cross our system once, and then vanish into the dark. Telescope the discovery. Early images showed a fuzzy coma surrounding a brilliant point of light. A tail of dust streamed behind it, shaped like a teardrop against the star field. Its estimated size, between 5 and 10 kilometers across, made it larger than Oumuamua, larger even than Comet Borisov, the second interstellar visitor seen in 2019. This was no pebble drifting in by chance. This was a mountain of ice and rock forged billions of years ago, now passing through our skies. But what stunned scientists most was its composition. Even at 3.5 astronomical units from the Sun, far beyond where most comets become active, Atlas was already releasing water vapor and oxygen emissions. This early outgassing suggested a nucleus rich in volatile ices, preserved since the dawn of another star system. A time capsule of chemistry older than Earth itself. Shooting star the scientific gold rush. Immediately, the world's greatest observatories swung into action. Hubble captured high-resolution imagery of its coma. The James Webb Space Telescope began spectroscopic scans, hoping to identify complex organics. The Vera Rubin Observatory tracked its rotation and brightness changes, revealing a nucleus spinning every 16 hours. Even amateur astronomers joined the effort, photographing its faint glow and feeding data into global databases. Each night, new mysteries emerged. Its coma grew redder, suggesting the presence of irradiated organics. Its tail showed unusual fragmentation patterns, hinting at fresh material being exposed. And its rotation appeared steady, but with subtle brightness shifts, as though the surface was uneven, scarred by eons of cosmic radiation. Atlas was not just an object, it was a laboratory, a natural probe, delivering alien chemistry directly to us. Milky Way origins in the galactic thick disk. Calculations of its galactic velocity revealed another astonishing fact. This comet came not from the thin spiral arms of the Milky Way where our sun resides, but from the thick disk of the galaxy, a region older, poorer in metals, shaped in the galaxy's earliest days. That means 3I Atlas could be between 7 and 14 billion years old, older than the Earth, older than the Sun, perhaps older than the Milky Way's spiral structure itself. To study it is to study matter forged in the dawn of time. If confirmed, this makes 3I Atlas not just the fastest interstellar visitor, but potentially the oldest object humanity has ever observed passing through the solar system. Alien head the debate, natural object, or something more. But as with Oumuamua before it, mystery breeds speculation. Some scientists, including Harvard astrophysicist A.V.I. Loeb, noted its unusual features. Its brightness seemed inconsistent with size estimates. Its orbital alignment, so close to the ecliptic plane of our solar system, felt suspiciously precise. Its early water outgassing, so far from the sun, puzzled conventional comet models. Could 3I Atlas be more than natural? Could it be, as some suggested, an artificial probe? A messenger not just from another star system, but from another civilization? Most astronomers reject the idea, pointing out that every strange behavior can be explained by natural cometary physics, volatile rich ices, irradiated crusts, rotation-driven outgassing. But the very fact that the question is being asked reveals something deeper. We are ready to interpret the cosmos through the lens of intelligence, not just geology. Globe showing Europe-Africa impact on culture and imagination. Beyond the observatories, the comet has already entered human culture. Headlines call it the ancient messenger. Artists paint it as a flaming spear from the stars. Writers imagine civilizations that might have once seen it in their skies billions of years ago, before ejecting it into interstellar space. Spiritual leaders describe it as a sign, a reminder that humanity is not alone in the cosmos. Schools and museums rush to tell the story. Children look up at the sky, knowing that for the next few months, a piece of another solar system is here, within our sight. Like Halley's Comet in ages past, Atlas is not just a scientific object. It is becoming a cultural event, shaping the way humanity sees itself against the backdrop of the galaxy. Scales hash the larger meaning. Why does this matter? Because every interstellar visitor changes our understanding of reality. Oumuamua shattered assumptions, showing us rocky interstellar bodies exist, slender and tumbling like shards of alien planets. Borisov revealed a more familiar cometary profile, with ices and dust like those of our own Oort cloud. Atlas, with its speed, age, and volatile richness, suggests entire new populations of objects, ancient survivors of star systems we may never see, but whose fragments drift across the galaxy and sometimes, miraculously, enter ours. And this is just the beginning. With the Rubin Observatory soon to scan the skies in unprecedented detail, scientists expect to discover dozens of interstellar objects every year. Some will be small, some may be enormous. One day, one may pass close enough for a spacecraft to intercept, giving us the chance to physically touch material from another star system. Electric light bulb, the future. Atlas, then, is not just a comet. It is a herald. It signals a new era in astronomy, an age where interstellar debris is not rare, but part of the fabric of exploration. It tells us that our solar system is not isolated, but open, porous, part of a galactic ecosystem of drifting relics. And above all, it reminds us of time. This single fragment, now glowing faintly in our skies, may have left its home star system before Earth even existed. It may have drifted across the galaxy for billions of years, untouched, unobserved, until now. For a few months, humanity can watch it, measure it, learn from it, and then it will be gone. Back into the dark, back into eternity. But the memory will remain, and so will the lesson, that the universe is alive with travelers, and that we, too, are wanderers, waiting for the day when we follow them into the stars. 3I, our Atlas, the ancient messenger from beyond the stars, Milky Way. Opening scene, dramatic voiceover. Now, with 3I, our Atlas, the third confirmed interstellar object to ever enter our solar system, humanity has been given a fleeting but extraordinary gift, a chance to study a relic from the deep beyond in real time. Our most powerful instruments, from Hubble to the James Webb Space Telescope, from the Rubin Observatory to TESS, are now working together in what astronomers call a symphony of surveillance. This synergy not only demonstrates how far our science has come, but it also prepares us for a future in which interstellar visitors are no longer rare accidents, but a data-rich frontier, discovered not once per decade, but dozens or even hundreds of times every year. And in this frontier, 3I, our Atlas, is our prototype, the first full test of humanity's ability to observe, analyze, and decode an interstellar traveler. Section 1. The path through the solar system. As it arcs inward, 3I, our Atlas, will reach its closest approach to the Sun, its perihelion, at just 1.36 astronomical units on October 29, 2025. But long before that date, opportunities abound. On October 3rd, it will sweep past Mars, where orbiters may catch a glimpse of its coma against the black. In March 2026, it will drift near Jupiter, close enough that Jovian missions might capture distant snapshots. Each vantage point will add a frame to the cosmic film. Each dataset will sharpen our understanding of how interstellar matter responds to solar heating, tidal forces, and radiation pressure. But beyond the science, the silent arc of this visitor carries a philosophical weight. Objects like Atlas are detached from their parent stars, flung outward by unknown cosmic dramas billions of years ago, surviving epochs of deep space drift. And now, we, a young species on a fragile planet, are lucky enough to witness their passing. Section 2. The first analyses. From the earliest days after discovery, astronomers began peeling back the layers of mystery. At the SOAR telescope in Chile, under crisp southern skies, a reflectance spectrum revealed subtle red shifts and a slight ultraviolet turnover, signs of complex carbon compounds and irradiated organics. Strikingly, none of the usual cometary gases, CN, C, CO, or OI, were detected, deepening the puzzle of how activity was taking place without conventional drivers. In July, coordinated teams around the globe used photometry and spectroscopy to measure the spin, just over 16 hours, with a light curve amplitude of 0.3 magnitudes. This painted Atlas as a steadily rotating, faintly active comet, but from a star system not our own. Hubble's gaze added numerical depth. Its high-resolution study of the coma revealed a dust mass loss rate between 6 and 60 kilograms per second, depending on particle size. That estimate led to constraints on the nucleus, no larger than 2.8 kilometers, but no smaller than 60 meters if carbon monoxide was driving the sublimation. Meanwhile, ultraviolet imagery from NASA's Swift Observatory captured OH emissions, betraying water sublimation. Calculations suggested a water release rate of 40 kilograms per second, meaning that at least 20% of the comet's surface must be actively venting water. That is far more activity than typical solar system comets. Section 3. The surprises. The surprises didn't stop there. By late July, Japanese telescopes confirmed Atlas's extremely red coloration, matching or exceeding that of D-type asteroids, dark, organic-rich bodies found in our outer solar system. Yet its brightness remained steady, with no violent outbursts. Polarimetric measurements from Europe showed unusually high light polarization, hinting that its dust grains were more pristine than those of native comets, untouched by repeated heating cycles around a star. Thermal models suggested exotic ices, possibly amorphous water ice trapping other gases, which could explosively release as sunlight penetrated deeper. And infrared instruments hinted at a dark, organic-coated surface, insulating the volatile interior until pressure built enough to break through. In short, Atlas looked less like an ordinary comet, and more like a time capsule of alien chemistry. Section 4. Speculation. Natural or artificial. But then came the speculation. Harvard astrophysicist A.V.I. Loeb, well known for proposing that Oumuamua might have been artificial, noted Atlas's unusually precise alignment with the solar system's planetary plane, as well as a mysterious forward glow anomaly. He suggested, cautiously, that it could be explained by something like a protective particle spray, a mechanism not unlike what a probe or spacecraft might deploy. His Loeb scale of artificial likelihood ranked Atlas at a 4, not proof, but enough to stir debate. Should we try to message it? Should we wait until after perihelion to see if it behaves strangely? Even some lawmakers weighed in, suggesting NASA consider repurposing Juno for a potential flyby. Within the halls of science, consensus remains conservative. Atlas is almost certainly natural. Yet the emotional gravity of the moment is undeniable. Once again, humanity finds itself staring into the night sky, asking, what if? Section 5. The coming months. As Atlas approaches perihelion, urgency grows. In September, sodium emissions were detected, rare so far from the sun, suggesting alkali-bearing minerals cracking free under thermal stress. Hubble's ultraviolet instruments mapped a gradient in the coma, showing seasonal effects on one hemisphere. ALMA began detecting trace levels of simple organics like methanol, supporting the idea of prebiotic chemistry beyond our star. Dynamical simulations suggested Atlas may have once passed through a dense molecular cloud, possibly altering its chemistry in ways we may now observe in isotopic ratios. Meanwhile, amateurs continue contributing long-exposure images, catching faint surges in brightness, possible outbursts, invaluable for modeling its structure. Even its faint ion tail tells a story, showing how interstellar dust reacts to the solar wind for the very first time. Closing, reflection. All these threads, the spectroscopy, the polarimetry, the photometry, the orbit models, converge on a singular truth. In just a few months of visibility, Atlas is teaching us more about interstellar objects than we ever dreamed possible. When it is gone, it will leave no trace, no return path. Only data, memory, and a reminder that we live in a galaxy alive with motion. That ancient wanderers pass by, silent, eternal. And that with every glimpse, our gaze extends farther, not just in space, but in time. If you found this journey through 3IO Atlas as thrilling as we did, hit that like button, subscribe for more cosmic stories, and let us know in the comments. Do you think Atlas is just another comet, or could it be something more? Thank you for watching. Until next time, keep looking up.